let's move on to the last section here, where we talk about daylight hours. And so the length of daylight hours, the time between sunrise and sunset, varies throughout the year. And we know this because, like the subsolar point, the circle of illumination is migrating, meaning that it's shifting from north to south and along the Earth's axis. And this all kind of translates to longer or shorter daylight hours in the whatever hemisphere we're thinking about. So the reason that there are less hours of day, or the days feel shorter, I mean, they technically are if you consider light from the sun to be day. The reason that happens in the winter is because we're in the northern hemisphere. And when we're in the northern hemisphere, what happens is, as we saw in the lecture, the subsolar point is actually pointed more directly here. Let's look at the analemma. The subsolar point is pointed more directly down here in the southern hemisphere, meaning that there's not as much, or the tallest tangent ray doesn't reach the North Pole. It's the other reason why the North Pole also doesn't get hardly any sunlight or very short days in the most wintry months possible. So with all that being said, that was kind of theory behind this, and you should know that by now. You will be practicing, because there will be some questions related to where's my example? There will be some questions with circles like this that I want you guys to fill in. Like, for example, where is the June solstice? Where is the December solstice? And essentially, I'm looking for you to sketch these things. Okay, I'm not going to do that here. You should have picked that up during the lecture. But you will be seeing graphics like this on the quiz, and then you will have to decide which ones, or match which ones actually match with the particular solstice or equinox that's called out. So try to translate that. That's what I'm getting across to you guys. Try to translate what you visualize here with this little exercise down here, okay? And what we're going to do here is we're going to calculate the hours and minutes of daylight for selected latitudes during an equinox, and actually I should erase this, during solstices in the northern hemisphere. So that's what we have to take into consideration. This is all northern hemisphere. The sum of the daylight hours and the minutes during the December and June solstice for each latitude must equal 24 hours. So this is a very straightforward, I know this looks confusing at first, but all we're going to do is we're going to calculate, like for example, how much time of daylight is there in the morning? This is the way I want you to think of it. How much time there is of daylight in the morning, and how much time of daylight is there in the afternoon and evening. So for example, 6 a.m. here at 0 latitude, okay? That means that we're talking about the equator, right? During the December solstice, if there's 6 a.m. here, what we're going to do is we're going to take noon, or I'm sorry, I shouldn't say noon because I just kind of, let's just take 12 p.m., okay? Generically noon as we know it, but 12 p.m., okay? We use that as our, that will be what we calculate from. So 12 p.m., what we're going to do is we're going to say 12, okay, I'm doing this answer right here. So 12, and I'm looking for how much difference is there between 12 and 6. And we know 12 minus 6 equals 6 hours, okay? 6 hours. So that means that there's 6 hours of day in the morning, or 6 hours of light in the AM time. The same thing, we're going to do it for here, 6 p.m. Well, we know it's the exact same answer. So 6 hours in the night. 6 plus 6 equals 12 hours of daylight. Now, as we get to something a little more complicated, let's go over here to the June solstice. Let's look at 4:34 at 40 degrees latitude, okay? So what we're saying here in the June solstice is that in the AM, the sun rises at 4:34, okay, in the morning, 4:34 a.m. So what we're looking to do here is, first thing we need to figure out, how many minutes are there between 34, like how many minutes exist after 34? And in that case, we could go 60 minus 34. Okay, and looking for my calculator. Here it is, 60 minus 34. Okay, so 26 hours, or 26 minutes, sorry. 26 minutes. Okay, so we know it's 26 minutes here. 26 minutes, and then that would put us, if we added 26 minutes to 4:34, that would put us at 5 a.m. Well, what's 12 p.m.? 12 minus 5, 7. Okay, so that means that in the morning, 7, I'll try to write this here. So that means there's 7 hours, 26 minutes of morning sunlight. Now, that we know that this is 7:26 for the AM, over here we see 7:26 for the PM. The instinct would be, and you could see that I erased this here, but the instinct says, oh, it must be the opposite amount of time is going to equal how much we have, because we know the opposite of 7:26 is 4:34. But the reality is we have to consider here, 7:26 would be in addition to or after 12 p.m. So the reality is what we're doing here is we're adding 7:26 from the AM plus, okay, 7:26 from the PM. Okay, and so what's that going to give us? Well, let's add 26. Okay, let's add 26 and 26. 52 minutes. Okay, there I am. I know this is hard to see, guys. I'm just going to write it here, actually. 52 minutes. Okay, 52 minutes. 7 plus 7. We're not looking for exact time here. Remember, we're looking for amount of time, not an exact time. So if we have 7 plus 7 equals 14, that's okay. 14 hours, 52 minutes. Okay, 14 hours, 52 minutes. That's the way this works. Make sure, like I said, that you're taking into account on this side that you're adding to 12 versus this one you're actually having to subtract first.